see the another example of this addition reaction, that is addition of fifth example, that is addition of H2SO4. So see this unsaturated system, propylene, when we add H2SO4, then there is an addition reaction. We simply split this reagent into two parts, so you get easy way to add this reagent to this substrate. So H and OSO3 H. So this is positive pole, this is negative pole. So it is easier way to add this. So in this we get addition product CS3CH, this negative part OSO3H gets added here, and hydrogen added to this N carbon, then we get the addition product. So propylene is the reagent, this is substrate, H2SO4 is reagent, and we get the product isopropyl hydrogen sulfate. Isopropyl hydrogen sulfate is the product we get here. Now see another example of addition reaction is oxymercuration demercuation. Demercuration. Oxymercuration demercuration. See, for example, we have taken this unsaturated system. What is the name of this system? 3,3-dimethyl 1,4, that is 1-butene. 3,3-dimethyl 1-butene. And this system, when mercuration means what? HgOAc twice is the reagent of mercuration in presence of water. So this reaction occurs and there is addition of this mercury. Addition of this mercury here. Addition of OH from water, and here CH2 adds this HgOAc. Okay, don't worry about how this happens, how this reagent gets added, because all the things we know in the mechanism, how this added, why this reagent added only to this carbon, why not this carbon. So all these things don't bother about right now, because we are just taking an overview of addition reactions, examples of addition reactions. We have to go into deep, one by one. We have to see all the reactions. We are just taking this overview here. Here, the first step, and the second step, when we add NaBH4, then we get removal of this HgOAc, and overall reaction is what? Addition of H and OH. This is the overall reaction, CH, OH, and here reduction of this. So this first step is the addition of mercury. So we call this step as a mercuration. And in the second step, we remove this mercury. So it is a demercuration, or simply this reduction, because this one is the reducing agent, NaBH4, as we know. So NaBH4 is a reducing agent. This reduces this group. So this second step is the demercuration. So we call this reaction oxymercuration and demercuration. So mercuration, demercuration is also a type of addition reaction. See another example for our information. Another example for our reaction, that is for our information, that is hydroboration reaction. Hydroboration reaction. Hydroboration reaction has been known that simply we have taken this unsaturated system and addition of B2H6, that is nothing but BH3 twice, that is B2H6. So it requires 3 molecules of this unsaturated system. So in the first step, see here CH, CH2 hydrogen gets added to the one and another, the boron group, and here same systems are added here. So in the mechanism we'll know how it happens, why 3 groups are needed, because it contains 3 hydrogen, it reduces simultaneously 3 groups. Okay, so hydrogen gets added to 3 groups, so 3 unsaturated system or 3 alkene molecules are required here. So this one. In the next step we have to remove this boron group. So this group is removed by the addition of base. So we say base hydrolysis is required for this, and OH gets added and we get the product CH3 CH2 CH2 OH. So we get alcohol product in this reaction. This is, so what is overall reaction? Overall reaction we have taken here the unsaturated system. That is propylene. Alkene is an unsaturated system. We have taken this unsaturated system and final product is what? We get the final product here. Final product here, instead of the unsaturated system, the double bond removed from here and one hydrogen added here, another OH group added here. So this is addition reaction, addition across double bond, removal of double bond and addition of 2 groups here, 2 groups or 2 molecules to get the product. So this is addition product here. See another example, glycol formation. Okay, or we say oxidation. When we add, suppose we have considered this unsaturated system, glycol formation. Glycol formation. Suppose that we have taken this, CH double bond CH2. So this is unsaturated system, simple propylene. When we add oxidizing agent KMnO4 or any per acid, so per acids are also oxidizing agents. So there is formation of glycol, addition of 2 OH groups. So diol formation or glycol formation, we say glycol. So this glycol formation is also another example of addition reaction. Here 2 groups are added across the double bond, removal of 1 bond out of this, and addition of 2 groups here, 2 groups, 2 molecules, 2 groups added here. So this is addition reaction. See another example, that is addition of hypohalous acid. Addition of hypohalous acid. So hypohalous acid, we know that HOX is a hypohalous acid. Suppose for example we have taken this unsaturated system. I have taken the same example because it is convenient to understand. We can take another unsaturated system, another alkene system here and apply the same principle here, same rules here. So CH3CH double bond CH2, that is propylene is a simple unsaturated system, primary unsaturated system, and this unsaturated system, when we add hypohalous acid, suppose we have added Cl2 in presence of water, then there will be formation of hypohalous acid, and we get the addition of halogens here, halogens, and also the addition of OH group also here. Okay, so addition of halogen, addition of OH group there. So this is another example of addition reaction. See one important reaction of organic chemistry. Important reaction of organic chemistry, that is ozonalysis. Okay, we know the important reaction ozonalysis, where ozonalysis also comes under the category of addition reaction, because ozonalysis took place to unsaturated system. Suppose we have taken here the unsaturated system. When this unsaturated system, comes in contact with ozone, O3. So 3 oxygen added here, 3 oxygens added across the double bond, and we get one compound where the 2 double bond removed from here. So CH, oxygen added first, second oxygen, third oxygen. So this oxygens added here, and this compound obtained, we call this compound ozonoid. Monoozonide, this compound is an ozonoid compound. So we obtain ozonoid as an intermediate compound. So ozonoid intermediate compound obtained. Now this ozonoid compound, when this ozonoid broken by using a reagent such as zinc, then we get removal of these groups and we obtain CH3, 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 C double bond OH. We obtain here aldehyde plus here another formaldehyde obtained here. So this is addition and breaking of ozonide reaction. Breaking of ozonide by using reagent. So this is one of the type of addition reaction where this ozone gets added across the double bond, and we get this disproportionation product that we'll see later. But this reaction is a type of addition reaction or example of addition reaction. Okay, so we saw here some general examples of addition reaction, such as addition of halogen, addition of halo acids, addition of water, addition of hydrogen, that is catalytic hydrogenation, addition of H2SO4, addition of hyperless acids, addition Oxymercuration Demarcuation, and this is ozone analysis. So these are some examples. Now we have to go in detail how these reactions occurs. As we know that carbon-carbon double bond, in carbon-carbon double bond, if we see this is an unsaturated system, carbon-carbon triple bond is an unsaturated system. So in this, supposing alkene, there are 2 bonds here. Okay, we know that one is a pi bond, another is a sigma bond, and we know that pi electrons are loosely held. Okay, loosely held electrons. So pi electrons are loosely held electrons, and these loosely held electrons are this system is ready to donate. Those who wants this electron, so ready to donate, and when this ready to donate, another reagent should be electron seeking. Electron seeking means what? It requires electron. Another system which requires electron. Okay, so it requires electron. This is ready to donate. So in this manner, this reaction occurs. And if reagent is electron seeking, then we call it electrophilic addition reaction. Okay, so electrophilic addition reaction, we have to see in detail this electrophilic addition reaction. Now this electrophilic addition reaction, we have to see here. In this reaction, the reagent is an electrophilic one, so it requires electrons. So we have to see the mechanism, and we have to start with the carbon-carbon double bond. First, we consider only carbon-carbon double bond. Then we go for carbon-oxygen double bond. The another type of addition reaction or carbon-oxygen double bond. Now, in this carbon-oxygen double bond, carbon-carbon double bond, we have to see the first mechanism. Okay, how it happens. We saw some example, but we have to see here the mechanism of addition reaction. Simply mechanism of addition reaction.